Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the spam filter, the system that keeps inboxes, comments, and messaging platforms free from unwanted and harmful content. We'll cover how Gmail, social networks, and review platforms detect phishing, malware, fake reviews, and bot-generated spam at scale. Whether you're preparing for a senior engineering interview or building content moderation infrastructure, this one is for you. Let's get into it. Welcome to Cloud Wizard. In this video, we're doing a complete deep dive into the spam filter, the system that keeps inboxes, comment sections, and messaging platforms free from unwanted, malicious, or low-quality content. If you have ever wondered how Gmail filters billions of emails per day, how social networks hide spam comments, or how review platforms detect fake submissions, this video is for you. We'll walk through the functional requirements, non-functional requirements, system architecture, end-to-end user journey, core models, low-level design, and the trade-offs that come up in a senior system design interview. Whether you are preparing for a FAANG interview or building content moderation infrastructure, let's get into it. Here is the core problem. A platform processes millions of messages, emails, comments, or reviews every minute. Hidden inside that stream is a constant flood of spam, phishing links, malware attachments, fake reviews, promotional scams, bot-generated comments, and social engineering attacks. If the filter is too weak, users are flooded with junk, trust drops, engagement falls, and security incidents rise. If the filter is too aggressive, legitimate messages get blocked, users miss important communication, and businesses lose revenue. The challenge is to build a spam filter that is fast enough to run at platform scale, accurate enough to protect users, and adaptive enough to keep up with spammers who constantly change tactics. Let's walk through the functional requirements. First, the filter must ingest content from multiple sources, such as emails, comments, direct messages, reviews, and forum posts, each with its own metadata and risk profile. Second, it must extract meaningful features, including text tokens, sender reputation, attachment hashes, links, images, IP history, behavioral signals, and account age. Third, it must classify each item into categories such as ham, spam, phishing, malware, or promotional, with a confidence score that supports nuanced decisions. Fourth, it must take action based on classification, such as delivering to inbox, moving to spam folder, quarantining for review, blocking attachments, or rejecting the submission outright. Fifth, it must support a feedback loop where users can report false positives and false negatives, and the system must retrain or adjust weights to improve accuracy over time. These 5 capabilities make the filter effective, not just reactive. Now the non-functional requirements. The filter must be extremely low latency. Email delivery or comment posting should not be blocked for more than a few hundred milliseconds. It must be highly accurate, with a very low false positive rate, because legitimate messages wrongly blocked are worse than occasional spam slipping through. It must scale horizontally to support billions of messages per day across many tenants and regions. It must be available and fault-tolerant, because a spam filter outage can quickly flood users with unwanted content. It must be adaptive, retraining models and updating rules frequently as spammers evolve. It must be secure, since the filter itself is a target for evasion and abuse. And finally, it must be explainable, so operators can understand why a message was flagged and users can appeal decisions. Here is the high-level system architecture. On the left, content producers send messages through email gateways, web APIs, mobile clients, or batch imports. The ingestion layer normalizes content and feeds it into a feature extraction pipeline. Features are passed to a real-time classification service that combines rules, machine learning models, and reputation scoring. The decision engine applies policy and decides the disposition: allow, quarantine, block, or rate limit. A state store records every decision and its supporting evidence. A feedback collector captures user reports and retraining signals. A model training pipeline periodically retrains classifiers and pushes updated models to the serving layer. An operations dashboard gives analysts visibility into volumes, accuracy, and attack trends. The key metrics to memorize: cold. Precision, the fraction of flagged messages that are actually spam. Recall, the fraction of all spam that was correctly caught. False positive rate, the fraction of legitimate messages that were wrongly blocked. Classification latency, the time from content ingestion to decision, usually measured in percentiles. Throughput, the number of messages classified per second per instance. Spam catch rate, a business-friendly version of recall. User-reported false positive rate, how often users complain about wrongly blocked messages. And model freshness, the time since the last model update. These metrics are what the business and operations teams actually care about. Let's trace the end-to-end user journey. A user receives an email in her inbox. Before it arrives, the message passes through the spam filter. The feature extractor parses the sender domain, headers, links, attachments, and body text. The classifier scores it as 98% likely to be phishing. The decision engine quarantines the message and adds a warning banner to the inbox preview. The user sees the quarantine and marks it as not spam. The feedback service records the false positive and raises the sender's reputation after verification. That night, the training pipeline retrains the model with the new label. The next morning, similar messages are correctly delivered, and the filter keeps improving with every user action. The core models and algorithms. Rule engines use deterministic patterns, such as blacklisted domains, suspicious keywords, attachment types, or sender IP ranges. Naive Bayes is a classic probabilistic classifier that estimates spam likelihood from token frequencies and is fast, lightweight, and easy to update. Reputation scoring tracks the trustworthiness of senders, IPs, domains, and accounts over time, often using decay and clustering. Machine learning classifiers such as logistic regression, gradient boosting, or deep learning models capture subtle patterns and interactions between features. A feedback loop reweights models and rules based on user reports and confirmed labels. The key trade-off is precision versus recall. Tightening the filter catches more spam but risks blocking legitimate content, while loosening it protects ham but lets junk through. Now the low-level design deep dive. The feature extraction pipeline is a DAG of tasks: tokenization, link extraction, attachment hashing, image analysis, reputation lookup, and behavioral feature assembly. Each feature is versioned and stored in a feature store for both online and offline use. The classification service runs a multi-stage ensemble: fast rules first, lightweight naive Bayes or linear model second, and a heavy ML model only when uncertainty is high. The decision store records every classification with features, scores, model versions, and final disposition, enabling audit and appeal. Feedback events are written to a queue, sampled, and merged into a training dataset with careful handling of delayed labels and user bias. Model training is scheduled or triggered by drift detection, and new models are A/B tested before full rollout. For scale, the system shards by tenant or message stream and caches hot features aggressively. Key takeaways for your interview. First, a spam filter is a classification and decision system, not just a keyword matcher, so emphasize feature extraction, ensembles, and policy engines. Second, always distinguish between real-time classification and offline model training, and explain why both pipelines are needed. Third, precision is usually more important than recall for consumer-facing filters, but the exact balance depends on the product and business context. Fourth, the hardest design challenge is the adversarial nature of spam. Spammers adapt, so the system must support frequent model updates, adversarial robustness, and abuse-resistant feedback. Fifth, explainability and appeal are critical for user trust, so discuss evidence logging, score transparency, and remediation flows. If you can walk through this system with these 5 points, you will signal strong senior-level design thinking. That's it for the spam filter. If this helped, like and subscribe, and I'll see you in the next one at Cloud Wizard. And that's a wrap on the spam filter. We covered the full picture, from ingestion and feature extraction through rules, naive Bayes, machine learning, reputation scoring, and the low-level design of the classification pipeline and decision store. If this video helped you, please hit that subscribe button and the bell icon so you never miss a new system design video. Drop your questions in the comments below. I read every single one. See you in the next one at Cloud Wizard.